Hi Chem students, it's Mrs. Hessel and welcome to today's lesson over atomic mass. Please have out something to write with and a calculator. I'm starting today on the bottom of page 5. Atomic mass represents the average atomic mass of all isotopes of an element. It is found by a weighted average technique, taking into account both the abundance of all the isotopes as well as their masses. And by abundance, I mean the percentage at which they're found. Are they the most common or are they the most rare? Atomic mass is measured in AMU, atomic mass units. 1 AMU equals 1.660538 times 10 to the negative 24th grams. The masses of all elements are compared to carbon-12, which is defined as having a mass of exactly 12 AMU. Atomic mass is the number on the periodic table that has several decimal places. So the atomic mass is this number here on your periodic table, 12.011 for carbon, taking into account the mass of all the different isotopes of carbon. Determining average atomic mass. So how do they figure this out? They use a weighted average technique, taking into consideration all the different isotopes of that element. So let's look at an example. Neon has 3 isotopes. Neon 20, which has a mass of 19.992 AMU, and an abundance of 90.51%. So this means that this is the most common type of neon found. 90.51% of all the different types of neon are this type. Neon 21 has a mass of 20.994 AMU and an abundance of 0.27%. So this one is really rare. And neon 22 has a mass of 21.991 AMU and an abundance of 9.22%. From this information, what is the average atomic mass of neon? So this is how we're going to figure it out. We're going to multiply the mass by the percent abundance, then add all the different isotopes together. So our first one is neon 20. I've got the mass times the percentage. Now you see the percentage is written in decimal form. I didn't multiply it by 90.51%. I multiplied it by 0.9051. So I took the percentage and I put it in decimal form by dividing by 100. Please don't forget to do this. Don't just multiply by the percentage number. You have to divide by 100 first. So what I got was 18.0948. I'm going to do this for the next two as well, for neon 21 and for neon 22. Then after doing this, I'm going to add my answers together and I get 20.18. This is the average atomic mass. Again, taking into consideration all 3 different types of our isotopes and their masses and the percentage at which they're found. You'll notice that this number should match the number you find on your periodic table, which it does, so I know I did this correctly. I hope you enjoyed today's lesson over atomic mass. Now you're going to spend some time practicing these problems with your teacher in class. If you need any help or assistance, please ask. Have a great day.